Welcome back. This is week 7 and we are in lesson number 1. We're looking at random variables and probability distributions. A random variable is a variable that has a single numerical value that is determined by chance for each outcome of a procedure. So when we talk about a random variable, when we're describing it or writing it down, we write x. We use x to represent our random variable. Let me use a thicker font. Let me make my font a little thicker here. So here's an x, and we put our value for our random variable in x. So maybe x represents an 80. Maybe this is a grade on a test. Okay, so this is our random variable. And then we randomly grab another test and find that someone else scored a 95. So this is actually, we're taking a bunch of values and we're randomly grabbing them from a set of exams, for example. So this is our random variable. X represents our random variable. There are two different kinds of random variables. One is a discrete random variable. A discrete random variable is a countable value. It has no fractional part. It would be like counting how many marbles do you have. You're not going to have half a marble, or how many people, you wouldn't have half a person. So discrete random variables are countable items. And here's an example of a discrete random variable. I've drawn a coin here. And here, my procedure is to flip a fair coin. So I'm assigning a numerical value of 1 for heads and 0 for tails. So my random variable x can take on one of two values. It can be a 1 if I flip and get a head, or my random variable can be 0 if I flip this coin and get a tail. So this is an example of a discrete random variable. Now the next kind of random variable is a continuous random variable. A continuous random variable has infinite many values that can be associated usually with a measurement. It's on a continuous scale with no gaps or interruptions. And an example here is I'm looking at milk. So we're talking about the volume of milk, and I have quart containers. And my first container could have a volume of exactly 1 quart. I could randomly be pulling these off the shelf, and so my first quart container actually has 1 quart of milk. But I could randomly grab another quart container here, and this one may have 0.98 quarts. And then I could go ahead and randomly grab another over here, maybe this one. Let's grab this quart. And it may have a little bit more than a quart, say 1.12 quarts. Well, each one of these values, the 1, the 0.98, and the 1.12, represent a continuous random variable. So it's not a whole number value always. In the first case, 1 is a whole number value, but it can have a fractional part. So it can be greater than or less than or between two whole number values. So this is an example of a continuous random variable. Okay, so now we're going to look at a probability distribution. And a probability distribution can be represented as a graph, a table, or a formula. And what it does is it gives us, it displays the probability for each value of a random variable. So here I have a die, and if I roll my die, there are 6 sides to my die. So if I roll it, the side facing up can be one of 6 possible sides. And the side that does face up, that value that it displays, whether 1 through 6 dots, is a random variable. So here on my table, I have my random variable x. And my random variable x can take on a value of 1 through 6. And here in my right-hand column, I have the probability that I will get any one of those random variables. So this is an example of using a table to represent a probability distribution. Now, what I'd like to do now is create a graph that will represent a probability distribution. Let me do this in a different color, and we'll circle graph in a different color. So in blue, we'll make a graph that will represent the probability distribution for rolling a die. So our y-axis represents the probability, and our x-axis represents the random variable. And the random variable can take on, it can be a 1, a 2, I'm in straightener mode here, a 1, a 2, a 3, a 4, a 5, or a 6. And each one of these takes on the same excuse me, probability, which is 1/6. So what I need, this is a histogram, so I need my histogram bar. So there's my first bar, and that means the probability of 1 is 1/6, or 16.6 repeating percent. I'm much more accurate with a fraction here. And so I'll go ahead and put my next bar in. Here's my bar for a probability of 2. And then I have my histogram bar for a probability of 3 and probability of 4. These are supposed to be the same width. I think the first one's not quite the same width. And probability of 5, and finally a probability of 6. Now they all have the same height. I think what I'll do is let me just move this whole thing over a little bit, just to the left, and it comes back. Okay, so the probability distribution graphically displayed is here, and so what I put is my left hand, my x-axis is represents p of x, probability of x, and my x-axis, excuse me, the x-axis represents my random variable x, and my y-axis represents the probability of x. And the line across the top, this line right across the top, it is the same height all the way across because they are the same probability. And in matter of fact, if a probability distribution is valid and we graph it as a histogram, the area underneath the curve, and in this case our curve is a straight line, the area underneath the curve, which is basically the height, which is the probability times the width, and here I have 6 bars of equal width 1, that will give us 100%. So the area underneath this curve should be 1. So here, that's an example of a graph. As we move forward in this class, we will look at probability distributions represented by formulas. Okay. Now here are the requirements for a probability distribution. There are 2 requirements for a probability distribution to be a valid probability distribution. The first is that, right here, that the sum of all probabilities, if you add them up, should equal 1. And all probabilities should be between 0 and 1. Any probability can be 0. If a probability is 0, it means it will not happen. If a probability is 1, it means it's definitely going to happen. So usually our probabilities are not 0 or 1, but between the two. So let's just check out flipping a coin. If we flip a coin, we will get heads. I'm going to grab a smaller font. Okay, so if we flip a coin, we're going to get heads or tails. Or we're going to get tails. And we've decided that when we get heads, we're going to assign our random variable a 1. And when we get tails, our random variable is assigned to 0. The probability of our random variable being 1 is 1/2, or 50%. The probability of our random variable being a 0 is also 1/2, 50%. Okay, so let's look at the first condition. The first condition says that the sum of our probabilities should equal 1. Well, sure enough, 1/2 plus 1/2, if we add them together, is 1. So we satisfied the first condition. The second condition says that each probability should be between 0 and 1. And sure enough, they're both 1/2, and 1/2 is in fact between 0 and 1. And I could put the equal sign, and it's between 0 and 1. So we've satisfied our second condition. So in fact, flipping a coin with the probability of 1/2 for heads and 1/2 for tails is a valid probability distribution. Let's take a look at this probability distribution, where my left column represents my random variable, and my right column represents the probability of each random variable. Is this a valid probability distribution? Well, if you look at each one of these values, for probability, they're all between 0 and 1. So I can say that all of my probabilities individually, taken one at a time, are definitely between 0 and 1. They're all greater than 0 because they're all positive, but they're all less than 1. They're a fraction and they're less than 1. Now if I add these up, what do I get? Well, if I add up this, the ones place, I get 5, 10, 15, 20. I get 20. So let's put a 0 down here and carry a 2 up. And now if I add these, I have 2, 4, 6, 8, 10. I get a 10. So I put a 1, 0, and bring down that decimal point. So sure enough, the sum of all my probabilities is in fact equal to 1. So I satisfied the second condition. So here are my two conditions. This is actually listed as the first condition. The sum of my probabilities is equal to 1, and each individual probability is between 0 and 1. So this is a valid probability distribution. Now, if we are given a probability distribution, and the probability distribution consists of a set of x values, those are our random variables, and the corresponding probability of getting each x value, then we can find the mean, the variance, and the standard deviation. So let's write the given. So our given is that we're going to be given every x value that's possible, and we're given the probability of each x value. Okay, so this this is what we are given. And if we know this information, if it's given to us, say, in a table, which would be very helpful, we can find the mean, the variance, and the standard deviation. We're talking about a population of values. So the variables we use for a population, for mean, we use mu. For variance, we use sigma squared. And for standard deviation, we use sigma. Okay? So this is what we use when we're talking about a population. There will be times when we're actually talking not about a population, but about a sample. So I just wanted to remind you that if we're actually not talking about a population, as we are in this case, but we're talking about a sample, then we talk about the mean. We will use the expression x bar, and the variance becomes s squared, and the standard deviation is s. But in this case, we're talking about a population. So let me show you the formulas that we need to find the mean, the variance, and the standard deviation. So here's the mean. To get the mean, what we do is we add up the following products. We take the sum of each random variable times its probability. It's as simple as that. And that gives us the mean. If we want the variance, then we are going to add up, again, the sum, this times the square of each random variable times its probability. And once we've done all of that, we subtract the mean squared, which we calculated in the previous calculation. And then finally, to get the standard deviation, we simply take the square root of the variance that we calculated in the previous line. So let's go ahead and try these three equations or formulas to find the mean, the variance, and the standard deviation using the following probability distribution. Here's a probability distribution. We're going to start by finding the mean. This is a population of random variables, and we're going to start by finding the mean. Remember, the mean means we need to sum up each random variable multiplied by its probability. So I'm going to do this underneath. So our first random variable is a 0 with a probability of 0.25. So we're going to say this is 0 times 0.25 plus our next, move that over, is a 1. And we're going to multiply 1 times its probability, which is 0.10. Notice that I'm summing these up. I'm summing up the different products because we're multiplying them. We call them products. The next value at x is 2, and the probability of the random variable 2 is 0.30. We've got 2 more to do here. So I'm going to move, let's highlight the next one. And now we have a 3, and the probability of a 3 is 0.20. And then finally, our last one is we have a 4, and the probability of a 4 is 0.15. So let's go ahead and work these out. Let me go ahead and remove the highlighting. We're done with that. And so now let's take a look at 0 times 0.25. Anything times 0 is 0, so this becomes a 0 plus. And our next one is 1. Oops, this is wiggling on me a little bit. Here we go. Our next one is 1. Move this over. There we go. Our next one is 1 times 0.1, so that's going to give us a 0.1, 0, plus. Okay, and our next one, let's move the highlighting over, is a 2 times 0.3. That's going to give us a 0.6, 0, plus. And 3 times 0.2 gives us another 0.60, plus. And 4 times 0.15 gives us another 0.60. So if we add these up, I'm going to go ahead and let's move these over a little bit. I'm moving things over to the left just to make room so I can put my answer on this same line. I want to have room for my other calculations, which is why I'm doing this. So if I add these up, 0.60 plus 0.60, I've got 0.606 3 times. That's 3 times 6 is 18. And so this is going to be plus the 1. So this comes out to be 1.9. So let me highlight that 1.9 down here. Okay. So that 1.9 represents mu, our standard deviation, our mean. This represents our mean. And this is our mean is the average. It's also known as the expected value. So there's our mean, mu. Okay, next calculation is to find the variance. Remember the variance? It means we are going to add up, this time, not x, but x squared times its corresponding probability. So we're going to add up all those products, and from that we will subtract the square of the mean, and we have that because we calculated that above. It's 1.9. So let's go ahead and work this out below. So this is equal to, and I'm going to copy from my previous line. It's going to disappear for just a minute while I copy it and paste it below. This line is very similar, except for now we are squaring each one of our random variables. And what do we get? Well, 0 squared, this is still going to be 0, okay? Let me highlight this. This right here, because it's 0 squared is 0, 0 times 0, 0 times 0.25 is 0. So again, we're not even going to count that one. It's 0. So let's go ahead and move on to the next one. This is being a little fussy here. Let me see if I can move this over. Yes, I can. Let's just cut it out. Okay. So our next one is here. We're going to take 1 squared and multiply by 0.1. Well, 1 squared times is 1, and 1 times 0.1 is 0.1, so this becomes 0.10 plus. Okay, let's look at the next one. We have 2 squared is 4. 4 times 0.3 is 1.2, so let's put a 1.2 down here. 1.20 plus. Our next one is 3 squared. 3 squared is 9. 9 times 2 is 18, so this is going to give us 9 is going to a 1.8, so this is a 1.8. And then our last one, is what? Our last one is going to give us a 16. 4 times 4, I'm going to use my calculator for this. 4 times 4 is 16, so 16 times 0.15, and that's going to give us a 2.4. So this last one right here, that value right there is 2.4. 2.4. So let's add these up. Let me move this over to the left. And one of the reasons I'm moving this over to the left is because I need to put in the square of the standard deviation. So actually I'm going to move all of this over to the left because I did not put the square of the standard deviation in. So let me put that in there. Okay. Over here, I have to remember to subtract, I'm sorry, the square of the mean. I think I said standard deviation, the square of the mean. And of course, with this whole calculation here, I have to subtract the square of the mean. That's 1.9 squared. So if I put this into my calculator, let's add these up. I'm going to add up these values right here. Okay, so 0.1 plus 1.2 plus 1.8 plus 2.4 gives us a value of 5.5. So this becomes 5.5 minus, and now I'm going to find what is 1.9 squared. Back to my calculator. 1.9 squared is 3.61. So minus 3.61. So I'm going to go ahead and subtract them on my calculator. 5.5 minus 3.61 gives us a 1.89. So that's our variance. Our variance is 1.89. And finally, our last step is to find the standard deviation. And the standard deviation is the square root of the variance. And that is the square root of 1.89. I'm going to go back to my calculator to find the square root of 1.89, and I get 1.374. So let's end it at 1.37, and there I have it. I found a mean. I found my mean, and my mean is 1.9. I found my variance, and my variance is 1.89. and I found my standard deviation 1.37. And this should help you out with your homework. And this concludes Lesson 1.